morning, everyone. Thank you very much for the invitation. It's my pleasure to present to you MindMaze here today. So the title of this presentation, MindMaze, A Story of Success, started really about this company, which was founded in 2012 by Ted Taji. And the mission of the company is to unlock the human potential through neurotechnology for learning and recovery. So really using new novel technology, mainly based on VR, for clinical and enjoyment applications. And the company started in 2012 as a spin-off of the Laboratory of Cognitive Neuroscience by Olaf Blanke in Lausanne. And it started really in a garage. I remember first time I visited MindMaze, I went to visit some of the people who are here now. They were working in a garage to bring VR to their applications. And then Tej was so successful to make the company real and to raise funds and to grow so much that now there are 70 employees and the company is growing and growing. The headquarters is in Lausanne, but there are MindMaze offices in San Francisco, London, and Paris. So I like the title of this presentation that the organizer suggested because it brings really the idea of neuroscience towards VR applications. And this is really where we come from, where Tej, me, Olaf Blanke come from. That is how we study neuroscience to understand how our brain generates experience. And generates experience of being here and now, what we call body self-consciousness, the experience of the self. And we believe that this happens through the elaboration and the integration of multisensory signals in the brain. And by understanding these, what I would like to do today is showing how you can use this knowledge to develop new virtual reality applications. So who has never seen this movie about the Rubberized Illusion? Okay, so there are still a bit of surprise. So this is the Rubberized Illusion. There is subjects who receive touch on his real hands that is not seen, and then he see a fake hand being touched. And look what happens. After a few seconds of this kind of visual tactile stimulation, he feels this illusion that the fake hand is his own hand, in such a way that he's scared if something approaches the fake hand. And you see how low technology this illusion is and how it works. And why this is the case? Because normally our brain processes information related to our own body, multisensory information to relate with our own body. We can trick our brain by presenting multisensory cues on our body and on external events, on artificial objects, as to induce sensation, feeling experience for the artificial objects. So you can do this with the hand, as in the Rubberized Illusion, with a real object, or you can do that in virtual reality with a real object. And this is the full body illusion, paper that Tej also published in Science from Olaf's Blanke lab, where the participants receive touch on their back, while at the same time they see an avatar being touched in synchrony. And after a while, they have the sensation that the avatar's body is their own body. And they have the sensation that they are shifting towards the avatar. So this is real research in neuroscience, and we did a lot of research trying to understand what are the mechanisms that our brain uses to process multisensory bodily signals. And normally, our multisensory body signals are related to our own body, our physical body in this space, which is here. What we can do with these illusions is deploying multisensory cues in such a way that our brains process body signals and signals towards artificial objects or artificial stimuli. And what we have shown, in particular with this full body illusion, is that why normally we integrate all the information related to our body in the space close to our body, which is called the peripersonal space. After some special condition of stimulation, our brain is able to process information from external objects that attribute to our own body. As our peripersonal space, the space limited around our body, expands to include artificial objects. Now, what we did in the lab is try to understanding what are the constraints, what are the minimal information that our brain processes to generate experience of our body here and now. And we wrote an opinion paper in Neuron where we highlighted these constraints together with Olaf Blanke, we'll measure later. And we defined what are the cues that our brain uses to generate experience here. Now, if you know what are these mechanisms, if you know what are these principles, you can understand that it's relatively easy, it's possible to alter your experience here and now. And then if you want to do virtual reality as to having people immersed in another environment, if you know the cues that your brain uses to generate the normal experience of your body, then you can do that. You can do virtual reality in a more powerful way. And I would say that there are mainly two mechanisms through which you can alter experience of being here and now in participants. One is, as I told you, by decoupling visual and tactile stimulation. Another one is through sensory-motor contingency. That is, whenever I do a movement, my brain predicts the consequence of my movement, so it expects my body to be in a current state. If I show an avatar which moves exactly in a coherent way as my motor program, what my brain does, it attributes the movements of the avatar to myself. And therefore, I believe that the avatar is my body. And this is a trick that has been used a lot to induce embodiment, sense of presence in virtual reality. So being equipped with this knowledge, what MindMaze tries to do is to bring this knowledge to the field and to realize new tools, virtual reality tools, for different applications. So MindMaze has a platform of multiple technology, so knowledge in neuroscience, virtual reality, augmented reality, artificial intelligence, robotics, content. And there are two main applications of MindMaze at the moment. The first one, and the one we are focusing more and more, is healthcare industry. That is virtual reality machine for rehabilitation. And the second one is, of course, media and gaming industry. So let me start from the core business of MindMaze at the moment, the medical field. We focus now on stroke. We develop a machine to rehabilitate stroke patients, but in the future, the same application, the same concept can be extended to other kind of application like Parkinson's disease, multiple sclerosis, pain, and so on. So what is stroke? If you have a vascular accident in your brain, you have a big lesion, which impairs your functioning in everyday life because you cannot move the first time and because you cannot process properly information. And this has a huge impact in everyday life of patients, has a huge impact on the health system. Virtual reality has been used now to induce some improvement in rehabilitation. And this is the Cochrane review, that is the agency in the US which evaluates the evidence in the clinical field. And this is a review about virtual reality rehabilitation. The question is virtual reality effective or not for stroke rehab? And what this review concludes is that there are some evidence that virtual reality can be used for stroke, but a lot of things has to be done. And I like a lot this paper, opinion paper by Adam Gasley in San Francisco about video games and virtual reality technology application for rehabilitations, where he raises an important point, that is virtual reality technology is very popular. It's very popular also in the healthcare system, but he says that many commercial claims are unsubstantiated and dismissed by scientific community. Enhancing brain function should not be viewed as a clever, profitable startup idea that can conquer with a large marketing budget, but high-level video game or technology development and rigorous scientific validation need to become the two-pillar foundation of the next generation of application for healthcare. So this is where I think MindMaze can make a difference, bringing together neuroscience, evidence, clinical evidence, and technology to do something which makes sense for patients. So why VR can be used for stroke patients? Because VR can be useful for increasing the rehabilitation dose. There is only one principle why rehabilitation works or not, that is how intense is the rehabilitation. And imagine if you have one-to-one relationship with a therapist, how long, how expensive, how is difficult to get enough rehabilitation for patients. There where technology can help a lot, because it can provide increased dose. Can increase motivation, because imagine doing all the time the same boring movement, or instead doing it in a context which is funny, enjoyable, virtual reality or gamified context. Then it allows to give exactly the exercise that you want to give, because it's fully controlled by the technology. And finally, if you can increase the dose and reduce the need of time from a proper therapist, you can reduce the costs. So that's where the advantage of virtual reality are. And MindMaze has developed two main products for stroke rehabilitation, MyMotion Pro and MyMotion Go. So this is MyMotion Pro, which is the hospital solution. The idea is bringing this machine to the bed of the patient as soon as possible to start rehabilitating them when they are in the hospital. So MyMotion Pro is marketed in CA and FDA, just got FDA approval. And the market where we are selling it are the following. And I think I have a movie about MyMotion Pro and how it works, because it's much easier to show in the movie. So you see that there is, this is, of course, it's not a real patient. This is a screen that the patient sees where there is an avatar, where there are objects the patient has to touch, to reach, to grasp in different conditions. And it does movement, and with these minimal markers and a camera, we record the movement and we animate the avatar. So that the patient can see exactly the movement he's doing embodied in an avatar context. So this way we provide the perfect training that we need. We can record all the kinematics, and we can also stimulate the brain areas of the motor cortex, which are activated not only when patients do a movement, but also when they see a body making the same movement in a sort of mirror-like mode. So this is the hospital solution. Normally in Europe, the model of healthcare for stroke patients is that it starts in the hospital and then patients move in rehabilitation center, longer-term rehabilitation center, and their patients feel better. They are more engaged, they have more attention. So you should provide exercise and tasks which are more motivating. And this is the second solution, which we call MyMotion Go. And so MyMotion Go is a lighter platform based on Kinect or our camera technology and lip motion, and then a series of activity like these which have been designed by physiotherapists and then are gamified by game developers, so to provide exactly the movement that the patient has to do during the physiotherapy, but in a nice context, in a funny context, in a motivating context as video games. So there are activities for upper limb, distal and proximal part, trunk, lower limbs, and so on. So there are many clinics which are now using and applying our technology all around the world. And we are doing a lot of testing and clinical validation about our products to get the best of information we need. And beside these two products for rehabilitation that I've shown, these are the other technology MindMaze is working on. Some goggles with the EEG equipment called neurogoggles. Our proper cameras, which are called Lyra. And then the last product has been launched just last week. It's called the Mask, which is an edge-mounted display, which has sensors to record the activity of the muscles of the face of the participants, so that when the user makes some facial expression, we can record and decode its facial expression, and we can use them to animate an avatar. So we can bring emotions into a virtual reality context. So you see this is a journalist trying the mask and doing movement, and you see how we can make the avatar doing exactly the same movement. So you can think to a lot of application of this technology in entertainment, in the communication field, but also again in the healthcare system. Okay, thank you very much for your attention, and thank you very much for organizing this conference.